Hi everyone, and thanks for joining us at this late hour and to the last block of our speakers. A very interesting presentation now from Fernando de la Vega, who is the CTO at Nanocell based in Israel, and he will talk about conductive pastes for laser-induced forward transfer process. With that, Fernando, the stage is yours.
Okay, thank you very much. First of all, it's a little bit strange to do this by Zoom. Actually, I don't know to whom I am talking, so hopefully it will be interesting. First of all, thanks for the team of TechBleak for having invited us to show and share with you the work that we are doing in the lift area. The work has been done by my team at PV Nanocell, Ayala Kabla and Semyon Melamed, and also in cooperation with the group of Professor Ioana Sergiotti from the National Technical University of Athens. Most of the work has been done in two projects financed in the framework of Horizon 2020. One is the IPERLAM, in which we developed some of the basic technologies, and now it's a Rolaflex, which is an ongoing project in which it's a consortium that is developing lift technologies to print flexible electronics. So first of all, in PV Nanocell, what we have done is we have developed a very interesting and nice way to make nano metal particles. We are making silver and copper nanoparticles. We have developed a process in which the nanoparticles are single crystal particles. Most of them, a very big majority of them, are single crystal. The range size is between 30 to 130 nanometers, and currently we are producing silver and copper particles. In the right side of the slide, you can see here a SEM electron microscope picture of our particles. These are silver. As you can see, the particles have very defined geometries, and this is because they are single crystal particles and they have very defined geometry. The process by which we make these particles is water-based chemistry, quite simple actually. We are not generating hazardous waste. It's a very efficient process regarding the yield of the materials, especially the metal, which is quite expensive. And we have scaled the production process, and we are able to make already tons of the nanoparticles. Being single crystal particles, these particles are very stable, which allows us to make very stable dispersions and inks. And by stable, I mean they don't agglomerate, they don't sedimentate, the shelf life is over a year. You can use it whenever you want. You don't need to do any pre-treatments or any other activities. You can leave them in the printers and go for your weekend, and then you can print without the problem coming back from your weekend. The storage is at ambient conditions, so it's a very nice and friendly materials to be used. We are focusing to use these nanoparticles to make inks and pastes for digital additive mass production technologies. Our focus is only on digital processes, and in this framework we are developing pastes for the lift process. The lift is a laser-induced transfer technology, in which, if you can see here in the diagram, we have a donor, which is a substrate which is transparent to the laser, together with the material that we want to print, coated on it. Then we will expose this donor to a laser ray, and in the place where the laser